that is 1 less than the number you started with. Which number is 1 less than? By the next number that is 1 less than this 2. What number is that? 1. 1. And I'm afraid you might think the next thing is to do what? To multiply again by 1 less than this, right? That would have been 0. No. We wouldn't do that. So you stop at 1. So my answer here means what? I'm going to have 6. So whenever you see 3 factorial, it means 3 multiplied by the next number that is 1 less than the initial number, 2 multiplied by 1, and that is going to be 6. However, the factorial notation has one special characteristic. What's that special characteristic? 0 factorial is what? 1. That's one special characteristic of 0 factorial. 0 factorial is 1. It's constant. Whenever you see 0 factorial is what? It is 1. But how do we use this factorial notation? We can use it in what? Permutation and combination. So permutation and combination are the main uses of factorial notation. And what is permutation? When we say permutation, permutation means we want to run some arrangement that has specific order. Arrangement with specific order is known as permutation. Arrangement without specific order is known as what? Combination. So I want 3 people to come here, and a girl must be the first person. Is that permutation or combination? Permutation. But I just want any 3 people to come here. That is what? Combination, irrespective. So when I write 3 letter words A, B, C, and I write another one B, A, C, I write another one C, A, B. Is this combination or permutation? Permutation or combination? Combination. But if I say, how many 3-letter words can I get from ABC that starts only with B? So here B becomes, get a special treatment. It must start with what? With B. So apparently you can think of what? B, A, C, B, C, what? A. This is what? Permutation. And you ask your number, your MTN, your Glow, your other network subscribers. What they do is that they run some permutation. They give the system some numbers. They say, oh, Glow starts with 0705 and generate any other 9 numbers like that. You understand? So that's how they do their work. So you just see 07051, 51, a lot of 51, then after then starts with 52, 52, 52, 52, a lot of 52, and after then 53, 53, 53, and a lot of 53. So this is what permutation is all about. But when it has to be combination, let's combine these people together. And that comes specifically when you are generating PIN for recharge card. I'm generating PIN for recharge card. Do I need any specific order? No, I don't need. So any 12-digit number or 14-digit number, if I can generate any random 14-digit number, then I have my recharge card ready. So with this, anybody can load anywhere. Is that fine? So that is just the analogy. And let's see how it works. Let's see the practical application of this. So let's start with permutation. So let's write the word mathematics. Mathematics is 11 letter word. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's an 11 letter word. So the question is, in how many ways can the word in mathematics be arranged? In how many ways can the words, letters in the word mathematics be arranged? And in this case, how do we go about it? We look at mathematics and say, oh, mathematics has some m's that are together. So we have two of the m's, M. So two of them are going to act as one entity. Why? Don't forget I told you in permutation, the arrangement matters. In combination, arrangement does not what? Does not matter. So if I'm picking this M first, it's tantamount to me picking the second M first. So you wouldn't know any difference between what? Picking the first M and the second M. So you combine the two M together. So we pick all the letters that are what? That are same. We pick them separately. Apart from M, T also. T comes twice, A comes twice, and which other letter comes twice? I think that's all. So you say the number of the letters, which is what? 11. Then you put factorial at the back, divided by the number of letters that what? That did repeat. So those letters that repeated, you start asking yourself, M repeated how many times? Twice. It becomes 2 factorial. Which other letter will repeat? A, right? How many times? 2. Another 2 factorial. T also, another what? 2 factorial. And no other letter repeats again. This is my result. Do we understand, please? So it's as good as that. Somebody said no? Yes or no? Okay. So apparently, how do we run this? You don't, maybe most times your options are not what? They are not in a single number. Meaning your options are just something like this most times, because they know that the calculator you are going to use cannot handle something as big as 11 factorial. 11 factorial is a billionth of number. So you wouldn't do that. So your option will look like this. So let's take another example. And in this case, let's ask ourselves, in how many ways can the letters in madam be arranged? How many ways can the letters in the word madam be what? Arranged. Don't forget I told you the first thing is to count the number of letters you have in that word given to you. So you do that by saying 1, 2, 3, 4, 5. So we have 5 words. So you say 5 factorials, all divided by how many times did any of these repeat? So you see M repeated twice. So we're going to say M here. So we count them, M 2 factorial. For A, how many times? 2 times. Another 2 factorial. Since this is less for the calculator to handle, your examiner is expecting you to be able to handle this. This one is very, very bogus, the number. This one is something you don't even need a calculator to handle. So what do? Don't forget 5 factorial means 5 times 4 times 3 times 2 times 1. All divided by 2 factorial is what? 2 times 1 times another 2 times 1. So you can see 2 times 2 here is 4. So all of this does cancel this 4. So 5 times 3 is what? 15 times 2 is what? So our answer is going to be what? 30. As good as that. Is that fine? So a quick one for you guys. Try how many ways we're going to be able to arrange this word now. So that's a short one for you. The word Australia. I'm not expecting your result to be a single number. Just leave your result in factorial form for me. So you mean 9 all divided by, is that all? Let's verify that. So Australia is a word that has how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9 factorial divided by how many letters repeat? Only A repeats how many times? 3 times. That is going to be what? 3 factorial. And that is just what it is. However, you should not forget, generally, when you have n permutation r, what does it mean? It means n factorial all divided by n minus r factorial. That's the final note on that. N permutation r means n factorial all divided by n minus r factorial. And from there, we go to combination. Combination is another thing that is also as important as permutation, because most times we do not keep preference. We don't want any preference for the situation on ground. Right, for instance, imagine there is an accident somewhere and you need people to help out. You select ladies from the boys, or you just say anybody, right? Anybody, right? So apparently you say anybody can help out. So in this time around, we just need some people. We don't want to know whether you're a girl or you are a guy. So that's just what combination is. And the general notation is n combination r is same thing as saying n factorial divided by n minus r factorial. Then you repeat the r again, r factorial. That's its own difference with permutation. In permutation, you don't repeat the r. In combination, you repeat the r again. So for instance, let's ask ourselves 3 combination 2. 3 combination 2 can be rewritten in words like this. I have 3 things, and I want to select them 2 at a time. So in how many ways can I pick randomly 2 at a time? So that's just it. So this is going to be 3 factorial all divided by 3 minus 2, right? Factorial, then what? 2 factorial. Which is 3 times 2 times 1, all divided by, here is 1 factorial, right? Which everybody knows is 1, times 2 times 1. And this is going to be what? 3. That's it. So, but there is a practical application of combination. For instance, let's say in this class now we have, let's say in this class we have 20 girls and 35 boys. In how many ways can 5 students be picked or chosen rather for a competition if there are 25 boys and 10 girls, provided that A, there is no preference, B, there must be at least, let's say, 3 boys. C, there must be 2 boys and 3 girls. So that one, we solve a lot of things. The maximum of the question, the complexity will not be above this for combination. All right, in how many ways can 5 students be chosen for a competition? If there are 25 boys and 10 girls, provided that the first condition is that what? There is no preference. So if I want to do, I can pack all the 5 girls, just pack any 5 girls from my class, go and represent. If I also wish, I can pack only 5 boys to come. So it's a kind of or, And you know, in mathematics, when we use or, is that multiplication or addition? Or is what? Addition. Please. Or in mathematics means what? Addition. What of and? And means what? Multiplication. So you think of both coming. So if there is no preference, I can choose only 5 boys. You understand? Or I choose what? Only 5 girls. So let's deal with the first case. There is no preference. Solution. The first case, since there is no preference, then you can have 5. That's how many girls do you have? We have 10 girls, right? I can choose all the 5 people from the girls, or all the what? All the 5 people from the what? From the boys. See the all. And apparently it has to be what? Plus. So I just add it up. Who does not understand that concept? Because it's at your discretion what to choose. So there is no preference. I can decide to pick any 5 people, or I pick 5 people. There is what they call federal character. I don't know if any one of you know about federal character. Federal character means in each state, when there is a job slot from the federal government, each state must have a particular slot. Okay? Majorly in the army, they use it a lot in the army. So that is it. So each state must have something. That is another thing. So, but if there is a job with a private organization, they might decide to pack all the people they need from one state. It doesn't affect. Once they have that, the technical know-how. So It can be all the 5 from the girls or all the 5 from the what? From the boys. And what is 10 combination 5? Is that not 10 factorial over 10 minus 5 factorial 5 factorial plus 25 factorial all over 25 minus 5 factorial 5 what? Factorial. So, and that is going to be my result. As simple, you just stop there. Yes. No, no, no. You can't just add this way. The one here. 5, okay, you want this 5, this 20 bar. But just, I know what I'm saying. Yeah, your options will come like this. Yeah, your options will come like this. So, then the big case, there must be at least 3 boys. If there must be at least 3 boys, you can have 3. Can you have 4 boys? Yes, at least. This is about English now. At least. So it can have 3 boys, 4 boys, or even everybody to be what? Boys. Is that fine? So B, at least, what does it mean? I can have 10. How many boys? 25, right? Combination 3. And it will now be and Abi. How many girls? If it says at least 3 boys, obviously, you know, the remaining will be girls. Since we need 5 people. Is that fine? And 2 girls. Or 4 boys, right? 4 boys. 4. And how many girls? 1. 10 combination 1. Or only 5 boys. Sorry, 25 combination 5. Who does not understand this? No girl again, so I leave the girls. All of us do not? You don't understand? Okay, this, let's take it again. This is about what? This is about the first one or the second one? The first one. No problem, no problem. It's okay. So when you say there is no preference, please, you can do as you wish. You understand? Apparently, I just limited this case to just have as you can just go for the boy, you go for all the girls, or you start choosing 3 boys, 2 girls, 3 girls, 2 boys, and what have you. But I only simplified and stop at this level. So it says if there is no preference, it's at your choice. The choice is yours, brother. You can choose all the 5 students to come from the girls' gender, or you choose all the 5 people to come from the boys' gender. You understand? So that is why I said all in mathematics, generally everybody knows is what? Addition. So it's either all the 5 are coming from the girls, or all the 5 are coming from the what? From the boys. And that's it. So I advise you, you cannot go for that, as a matter of fact. So you just stop here. Your options are going to be like this. So you just choose anything that has to be like this. The second one says at least 3 boys. At least 3 boys means what? We should not have less than 3 boys. Yes. So I can choose 3 boys. Then don't forget, I need how many people to represent me? 5. So I cannot choose only 3 boys alone. I will have to choose the remaining from the girls, right? That's why it is 3 boys and 2 girls. And means multiplication. Or 4 boys and how many girls now? Only 1 girl. Or all of them are just 5 boys. Is that fine? And with this, we can have 25 factorial all over 20. Obviously, this is going to be 22, right? Then 3 times 10 factorial all over. This is going to be 8, right? Then 2 plus, I told you all means plus. So you put plus 25 factorial 4 factorial and 21 factorial times 10 factorial 9 factorial, right? Since I don't need to put 1 or I still put it. Plus again 25 factorial all over 20 factorial 5. That's the answer. So you cannot go further, please. This is how your option will look like. Crazy? Because they know the calculator you are using cannot handle this. So they just leave the option this way for you. Now, when it has to be combining people, see now, it, can 5 students be chosen? When it has to be choosing things, when you choose things, you are combining. You understand? They give you a kind of a tray that has a lot of candies. They say choose any 3. So you choose the first one, right? Then you choose the second one, you combine it together. So the word combination is coming from the word choosing. You understand? So when it has to be arranged, you know it's permutation. When it has to be choosing, it becomes what? Combination. Another question, please. So if this is going to be, then please, everybody should try the third one. If there must be 2 boys and 3 girls. This condition now is not bending. There is no or. It has to be 2 boys and 3 girls. So do this. Addition. Addition. So you wrote addition here. All right. I think it's good to know you are getting it right. So that last case is going to be 2 boys. So out of 25 boys, I pick 2, and out of 10 girls, I pick 3. As simple as this. So you might even be lucky that the option will just come this way. You might be lucky. So that's going to be 25 factorial, all divided by, that's going to be 20 what? 3. Then 2 factorial times 10 factorial, 7 factorial, 3 what? Factorial. But before I leave combination and permutation, there is a special case that deserves a special treatment. Imagine we have what we call round table. The round table discussion is one in which you have something like this, circular arrangement. And there are seats around, and there is obviously people sitting around the table. So in a round table arrangement, it's just a special case that is not as straightforward as this. So whenever you have a round table arrangement, let's see how that is done. So let me pick up a question and let's see how we can do justice to it. A case of a round table arrangement. In how many 6 people be seated in a round table just in how many ways can 6 people be seated in a round table meeting? So, and you ask yourself, is this supposed to be combination or permutation? If you are afraid it's not any, obviously. I'm afraid it's wrong. It's not. It's not both. But because you just see 6 people, we don't have an idea whether they look alike. We don't have idea if we have some identical things among them. I don't know. It's just as talk. But no, when you have a case of round table, think of this. Your number of ways will just be what? N minus 1 factorial. Is that straightforward? Do you understand? Round table arrangement is n minus 1 factorial. Don't forget n minus 1 factorial for a round table arrangement. So in this case, our n is 6, right? So our result will just be 6 minus 1 factorial, which is what? 5 factorial. What is 5 factorial? I think that should be 120, right? And that is 120 ways. So it's that simple. And I pick one. Let's see. Okay. All right. I have this. And let's take this as your classwork. So the question says, how many classwork, how many possible All right, that's your question. A quick one. How many possible ways are there of seating 7 people, P, Q, R, S, T, U, and D, at a circular table? Oh, so fast. So people are still working on it. I have other options, so let other people get the other options. We all have it? 720. 729? Right. And that's correct. Because here we're going to look at what? We're going to look at number of people are 7. We just say 7 minus 1 factorial. That becomes what? 6 factorial. What's 6 factorial? 6 times 5 times 4 times 3 times 2 times 1. Everybody knew 5 factorial is 120. 120 times 6 is what? 720. As good as that. All right, a quick one for you. I just want to give you some 5 different questions on this before we go to another topic. All right, everybody can write. In how many ways can the letters of the word elation, elation, in how many ways, can 9 people be seated if 3 chairs are available? In how many can 9 people be seated if 3 chairs are available? Oh, so fast. So fast. Some people are still struggling with that. Please do that. Do that. No, no, no. Please stop using calculator. All right, no noise, please. No, no, no. Leave your answer. Factorize. Multiply out all the factorials. Multiply out the factorials. So do we all have the answer to that? Please do well, do well, do well.
With Glovo, you've got the city at your fingertips. Got cravings? Order on Glovo. Running low on toiletries? Glovo's got you. Download Glovo. Order anything you want and receive it in minutes.
Improve ROI with Google Ads. Like this business low-key achieved over 500% return on investment. Work together with Google's AI-powered ad solutions to find new customers. Unlock
to diseases and microorganisms are more suitable to survive in an environment. So let's take a look at this. Which event is unique to meiosis? A. Chromosome condensation. B. Spindle formation. C. Pairing of homologous chromosomes. And D. Chromosome alignment. And that's option C. Pairing, because it is that particular pairing of homologous chromosome that we refer to as crossing over. When the homologous chromosome, when they cross, when they become paired up, and then they become joined together at the centromere, they cross each other, exchange genetic material. This only occurs or happens during meiosis. So the event that is unique, that is only present in meiosis, is the pairing of homologous chromosomes. Pairing of homologous chromosomes does not occur during mitosis. The next question. Okay, which phase comes right after G1 in the cell cycle? You see on the board, G1, that's the first stage. After that is the synthesis stage, S stage. After the S stage is the G2 stage, and then after G2 stage is the mitotic stage. So the stage that comes right after G1 in the cell cycle is the synthesis stage. Now, by the way, cytokinesis is not one of the stages in a cell cycle. As you can see on the board, these are the four stages in a cell cycle. You have the G1 stage, gap 1. After that, the synthesis stage. I told you it is this particular stage, synthetic stage, that duplication of chromosomes actually occur, or duplication of DNA. So the phase that comes right after G1 is the synthesis or synthesis stage, the S stage. The next question. Next question, please. Okay, chromatids are pulled apart during which stage? Chromatids are pulled apart.
Combination 3. You understand? So it can be 9 factorial, 9 minus 3.
In anaphase. It is at anaphase that the chromatids are pulled apart, and then part of the chromatids go to the north pole, and then part go to the south pole. Don't forget, at metaphase, the chromatids will line up at the equator, but at anaphase, they will pull apart, and then the certain chromatids go up into the south pole, and the other chromatids go into the north pole. So that's for that. Let's go to the next one. Okay, while that is being sorted, know that at prophase. Okay, all right. So spindle fibers attached to chromosomes at the dash. Now, spindle fibers are those protein substances that help to pull up the chromatids to the poles during the anaphase and the early telophase. It is the kinetochore, all right? It is kinetochore that helps to attach spindle fibers to chromosomes. So the correct answer here is the kinetochore. Kinetochore helps to attach the spindle fibers to the chromosomes or to the chromatids. The next question. You want to write the questions? Okay, so number 20 now, it says, which of the following is not a part of interphase? Which of the following is not a part of interphase? The first three stages of cell division are part of the interphase. What are the first three stages of the cell cycle? The G1 stage, the synthesis stage, and the G2 stage. So when they are asking for the resting stage, it is the first two stages out of the four stages in cell cycle. There are four stages in cell cycle, as you can see them on the board. The gap 1 stage, that's when the cells become bigger and increase in size. And then the S stage, that's when the DNA replication occurs. And then the gap 2 stage, that's where the growth of the cell continues. So G1, S stage, G2, these are the three stages that make up the interphase. The only stage or the only phase that is not part of the interphase is the mitosis stage, which is the M stage. So please take note of that. So which of the following is not part of the interphase? That would be the mitosis stage. That is the M stage. Number 21. In meiosis, homologous chromosomes separate during dash. In meiosis, homologous chromosomes separate during dash. Now, if you look at this, it happens at anaphase 1. Chromatids, the same stage where chromatids actually separate and they become pulled to opposite poles is anaphase 1 in meiosis. That same stage, that's when the homologous chromosomes separate. So, homologous chromosomes separate during anaphase 1. Not only that, chromatids separate and become pulled to opposite parts of the cell also during anaphase. Don't forget, at metaphase, what just happens is the chromatids just line up at the equator. At anaphase, two major things happen. The chromatids are pulled apart, and also the homologous chromosomes, they also separate during anaphase 1. And if you look at prophase 1, it is during prophase 1 that crossing over occurs. So in case you come across a question like that, they can ask you that in which of the following stages during meiosis does crossing over occur? Crossing over or synapses occurs during prophase 1. And we have 5 stages in prophase 1. And by the way, prophase 1 is the longest stage during meiosis. What did I say? The shortest stage during cell division was anaphase. But the longest stage during cell division or meiosis is prophase 1. And this prophase 1 is made up of 5 stages as well. And the stages are, you have the leptotin stage,
One simple question. I want to
you have the Paschitin stage, you have the diplotin stage,
So, how many men are available?
you have the zygotin stage,
How many men are available?
and then you have the last one, the diakinesis stage. So in case you come across question asking you which of the following is not part of prophase 1, or which of the following stages is not found in prophase 1, these are the 5 stages in prophase 1: leptotin stage, the Paschitin stage, the diplotin stage, the zygotin stage, and of course diakinesis. And it is during this zygotin that synapses actually happen.
That's going to be 3 factorial.
Synapses or crossing over, it occurs
Factorial, 3
at zygotin stage. Or at times they can ask you at which of the following stages in meiosis is synaptonema complex formed. Now even from the word synapses,
3 is 3.
alright, that's where the word synaptonema complex comes from. So synaptonema complex is formed during zygotin. So please take note of that. Prophase 1 is the longest stage in meiosis. Not only that, prophase 1 is further divided into 5 stages. And the 5 stages are on the board: the Paschitin, the leptotin, the diplotin, the zygotin, and of course the diakinesis. Let's go to the next question. The term synapses refers to dash. You should be able. Tell me this. What is the answer here? Chromosome duplication, chromatic separation, pairing of homologous chromosome, cell plate formation. Say that again. Pairing of homologous chromosomes. It is when homologous chromosomes actually pair up.
Binary operation is
This is it.
between 2 quantities, or let me just say 2 variables. Now, the relationship between the 2 variables are
What the meaning of pairing? You understand? When they become 2 and they pair up and they become joined here at the centromere, that is what we refer to as synapses or crossing over. You can see this chromosome crosses over this chromosome to become joined at the centromere. It is actually the crossing over. This place where they cross over, they will interchange genetic material there. That's what causes or bring about genetic diversity. And that's one of the advantages of meiosis. When you have genetic diversity or differences or genetic variation, it will make that particular organism to be more able to adapt to its surrounding. Not only that, organisms like bacteria make use of this to be able to survive and resist antibacterial drug. Some people can be suffering from one particular bacteria infection or the other, and even though they are taking antibacterial drug, it's not working probably because the bacteria are actually resistant to the drug. That is one of the advantages of this variation here. The next question: during which phase does the nucleolus disappear? I've mentioned that in my intro the other time. The nucleolus disappear at the prophase stage. Two major things occur at prophase stage. The chromosomes, they do what? They condense and they become more visible, and the nucleolus disappear. Those are the two occurrences at prophase stage. The nucleolus disappear, the chromosomes become thickened, they condense, and they become more visible. The next question: which phase of mitosis is the shortest? I believe everybody knows that. The anal phase. So, don't need to waste time on this. The next one. Okay. Which of the following is a reason for mitosis? Which of the following is a reason for mitosis? Is it for sexual reproduction? That's for meiosis. Is it for genetic variation? I've explained. That's for meiosis as well. Formation of gametes. That's for meiosis. What mitosis is used for and important for is growth and repair. I told you the other time that when mitosis occurs, it helps in the repair and healing of wounds. So growth and healing of wound, repair of dead and worn out cells in the body, these are some of the importance or applications of mitosis. And why they get that up, you should be able to know that meiosis and meiosis, even though the two of them are type of cell division, they perform different functions. Mitosis helps majorly in the growth of an organism, in increase in size of an organism, and also in the repair of dead, old, and worn out tissues. And also, they also help in healing of wounds. Meiosis, on the other hand, they help in genetic variation. They help in reproduction by production of gametes like egg or ovum in women, and also sperm cell or spermatozoa in men. Let's go to the next question. Chromatin condenses into visible chromosomes during dash. That will be prophase as well. I've mentioned that the chromosome become condensed, they become more visible during prophase, and then nucleolus also disappear during prophase as well. If you're looking at telophase, that's the end stage. That's the last stage during cell division. What happens? There are two major things that happen at telophase. Number one, there is cytokinesis. The cytoplasm will divide into two during mitosis or into four during meiosis. Another thing that occurs during telophase is the nucleolus that has disappeared at prophase will now reform in telophase. And also the chromosomes that has condensed at prophase will now become less visible at telophase. Number 27 now. Okay, which of these does not occur in mitosis? A, DNA replication. B, spindle fiber formation. C, nuclear envelope breakdown. And D, chromatic separation. You guys should be able to tell me that. Which of these things does not occur in mitosis? Of course, DNA replication. If you look at the board, I told you that DNA replication occurs at what stage? At the synthesis phase, and the mitosis stage is still here. So the replication of DNA occurs at the S phase, not in mitosis. The next question now. Okay, which structure divides during cytokinesis? I just mentioned that few moments ago. What did the answer here? You forgotten the cytoplasm. That is even the meaning of cytokinesis. I was telling you that cytokinesis occurs during the telophase. When the cytoplasm divides into two, we refer to it as cytokinesis. So it is the cytoplasm of a cell that undergoes division during cytokinesis. Let's go to the next one now. Which stage of meiosis resembles mitosis the most? And it's a very common question too. So there is a particular stage of meiosis that resembles, that is almost exactly like the mitosis. So which stage of meiosis resembles mitosis the most? Anyone? Would it be prophase 1 or metaphase 1 or maybe meiosis 2 or meiosis 1? It is the second meiosis that behaves exactly, that is almost exactly identical to mitosis. Meiosis 2 is identical, resembles most mitosis. So the stage in meiosis that resembles mitosis most is the second meiotic division. That's another name for meiosis 2. Don't forget, meiosis occurs in two stages. The first meiotic division is meiosis 1. The second meiotic division is meiosis 2. During meiosis 1, two daughter cells are produced. During meiosis 2, two daughter cells are produced. That is why in all, 4 daughter cells are produced. If you compare that with mitosis, there is only one mitotic division. There is no mitosis 1 and mitosis 2. No. That's why you only have production of only 2 daughter cells. So it is meiosis 2 that resembles and identical to mitosis. Let's go to the next one. Okay, which of the following is not a result of mitosis? Healing of wound, I've told you today. Healing of wound is as a result of mitosis. Growth of organism is also as a result of mitosis. Gamete formation is as a result of what? Of meiosis. And then replacement of dead cells is as a result of mitosis. Replacement of dead cells, replacement of worn-out cells, replacement of old cells, all of them are as a result of mitosis. But formation of gamete is formed. Gametes are formed during meiosis. That is why gametes are always haploid in nature. So for example, sperm cell will only have 23 number of chromosomes in it. Egg will only have 23 number of chromosomes in it. For example, during reproduction, you have a man with X, Y chromosome, and then you have a woman with XX chromosome. During sexual reproduction, the Y chromosome can be released from the man, and because chromosomes are haploid in nature, the Y chromosome will contain 23 number of chromosomes. The X chromosome is released from the woman. Not only that, the X chromosome, the chromosomes in gametes, either in sperm cell or in egg, are haploid. It will also contain 23 number of chromosomes. In this particular offspring now, XY chromosome tells you it's going to be male, will now contain 23 plus 20 number of chromosomes, making 46. So please take note that in the body, in body cells, there are 46 number of chromosomes cell. But in gametes, like in sperm cell, there is 23 number of chromosomes, haploid number. In egg or ovum, there is 23 number of chromosomes as well. The next question. Okay, it's similar to what I was talking about earlier. A human skin cell contains 46 chromosomes. After mitosis, each daughter cell will contain A 23, B 46, C 92, and D 12. Don't forget, during mitosis, there is no division of microsome of chromosome. The same number of chromosome in the parent will be the same number of chromosome in the daughter cell. So which means if a human skin cell contains 46 chromosomes, after mitosis, that same 46 number of chromosome will be present in the two daughter cells. It is only in meiosis that the number of chromosomes in the daughter cell in the gamete or ovum can be lower, but in mitosis, the number of chromosomes remains the same. It never changes. The 32nd question. In meiosis, genetic variation is introduced during dash. A. Anaphase 2, B. Prophase 1, C. Telophase 1, and D. Cytokinesis. I told you it is during prophase 1 that crossing over occur, and it is when crossing over occurs that there would be introduction of genetic variation. So in meiosis, genetic variation occurs at prophase 1. Let's take note of that. During prophase 1, there is exchange of genetic material. I told you exactly during zygote, that's where crossing over occurs, and it is when crossing over occurs that the two chromosomes can exchange genetic material, therefore bringing about genetic variation. And I told you, genetic variation is good for organisms, you and I. It enables us to be able to fight against infections and diseases. It even helps microorganisms like bacteria, because it can make bacteria to be resistant to drug as well. The next question. Okay, in
Why not just do this faster now? It will be minus 5 over 2. So the minus will come up. All right, let's do. Okay, a lot of people have had minus 2.5. Let's see if that's actually going to be the result. Can we go on? Can we go on? Now, here, what does it mean? 3 in operation with minus 2 means what? My A is what? 3. My B is what? Minus 2. And I just come to the formula, I put it in. Is that fine? Very simple. And what are we going to have? We're going to have what? 2A 3 squared plus 3 minus 2 squared all over 2 times 3 times minus 2. Hopefully it's fine this way. Are you sure? 3 squared is what? 9. 9 times 2 is what? 18. Minus 2 squared is what? 4 times 3. 12 plus 12. And divided by 2 times 3 is 6. Abi? 6 times 2 again is what? 20 minus what? 12. And this is going to be 30 over minus 12. And you see 4 can go now. Okay, 6 can go. Minus 6 all over 2. It's 5? Okay, 5. We go 6, right? Will be 5, yeah. Minus 5 over 2, and that's your result. That's still minus 5 over 2. So minus 2.5 is the same thing as what? Minus 2.5. Now the last one here is what? Is going to be, can I rub this off? Oh. Now, when you see, most times your examiner is bringing something like this. Most times, because they know it's too simple, so they wouldn't want you to have the answer that simple. So they bring something that has two brackets. Please, it's very simple. Do your BODMAS. You still remember your BODMAS, right? Bracket first, isn't it? So you solve your bracket first. So I'm going to look for what? 1 in operation with minus 1. Are we together? Are we? 1 in operation with what? Minus 1. Here my A is 1, B is what? Minus 1. And that's going to be A squared, 2A squared, 2 into 1 squared plus 3B squared, 3 to minus 1 squared, all over 2 times 1 times minus 1. We all understand this? Do you understand? The bracket, we solve the bracket first. Is that fine? So inside the bracket, whatever our result is, we now solve it with these two. So this bracket is the most important one for us now. We treat it the way we had treated the other ones. Is that fine? So that's going to be 1. A is 1 here. B is what? Minus 1. We put it into our formula. Is that it? So that's how we got it. And this is going to be 2, right? Obviously, minus 1 square is 1. So 2 plus 3 all over minus 2. And this minus, that's 5, minus 5 over 2, right? Oh, so funny how 3 in operation with 2, with minus 2 gave us the same result it is. So now this is my old bracket here is minus 5 over 2. Is that fine? Young man, what do? We now combine 2 in operation with the bracket, which is what? Minus 5 over 2. Is it fine now? So it means this time around, A is now 2, B is what? Minus 5 over 2, which I believe everybody can solve. Please do well to quickly do justice to that. Oh. If we can get there, have to be, have to loss. Probability. There's no done probability, no done investigation. I saw very important. Logarithm. Okay. So here is going to be 2. The formula is 2a squared, 2 into 2 squared plus 3b squared minus 5 over 2 squared all over 2ab, 2 times 2 times minus 5 over 2. Do we all understand this? So apparently we just put in a as 2, b as minus 5 over 2. And that's going to be 2 times 4 plus 3 times 25 all over 4, all divided by minus, that's going to be minus 20 all over 2, or just minus 10. Minus 10. Then let's look at this. This is going to be what? 8 plus what? This is going to be 75, right? All over 4, all over minus 10. 4 times 8 is what? Is 32 plus 75, all divided by 4, all divided by minus 10. This is going to be what? 107. It's going to be 107 all over 4 times 1 over 10 in minus. Is that fine? And this is going to be minus 107 all over 40. Many of us got that? Oh, thank you. If you got that, kudos. Let's quickly do a twin operation on binary before we leave binary. The twin operations are what? inverse and identity elements. Inverse elements and identity elements. So let's start with identity element. What are identity elements? Identity element is just or the set of elements that does not change the result of something, and they behave like one in your normal algebra. So 1 times anything gives you that thing, isn't it? The same way identity element in operation with anything will still give that thing. Can I explain this? The question alone. Oh. So identity elements. Identity elements are E. They are represented as E. So whenever you see E, they mean identity elements. What is their property? Identity elements, when you have A, for instance, in operation with identity elements, it will still give you the same result. Don't forget I told you identity elements behave as though they are one in what? Your normal algebra. So they behave like one. They just behave like what? One. So identity elements, they behave like one. So A in operation with E is still giving me A, meaning E has no effect on A, isn't it? It means that E does not have effect on A. And you ask yourself, 20 times 1 is what? 30 times 1 is what? 45 times 1 is what? 45. So it's behaving as if it's 1. Please don't miscode this. Identity element is not 1, but its behavior is like 1.
Eat lots. So penguins are able to adapt to cold environment or weather conditions because of the presence of both the fat layer and dense feather. The next question. Okay. Which is an adaptation of animals to conserve water? Which is an adaptation of desert animals to conserve water? A. Eating grasses. You know there is no correlation between eating grasses and conservation of water. Option B, sleeping during the day. That's the correct answer. I've mentioned that while I was explaining the other time. One of the ways that a desert animal can conserve water and prevent excessive water loss is by ensuring that they are inactive during the day. That's by sleeping during the day. We call it aestivation. If you look at option C, living near rivers. How do you get rivers in the desert? For example, that's why there is little amount of water. Or look at option D, drinking often. Drinking what exactly? Because there are actually few amount of water. So that's that. So the correct answer here would be option B, sleeping or remaining inactive during the day. The next one, which of the following is a defense adaptation? Now, there are various adaptations. There are structural adaptation, there are behavioral adaptation. Let's take care of this. And then there are defense adaptation. Now, there are some animals that they have certain things on their body which makes them not to actually be easily grabbed by other animals. For example, look at porcupines. All right, porcupine has spines. I mean, you guys know what porcupines are. Porcupine has spines on their body, like needles or nails, which makes it when they see a predator or humans, they raise it up, they actually seem bigger than they are. You can't grab them because those spines are actually very, very sharp, and they can pose damage to whatever predator, be it humans or other animals that see them. That is what we refer to as a defense adaptation. Not only that, there are some animals that they produce certain foul smell. They produce certain things that when a predator goes close to them, they produce this foul smelling liquid that makes those predators to move away from them, which means that the predator will see as if that particular animal is unpalatable, that they are not edible because of the foul smell originating from them. Not only that, we have structural adaptation. Structural adaptation has to do with what is present on a particular organism that can make it to become adapted to the surrounding. For example, let's look at bird. Bird has wings, which enable them to fly from one place to the other. They can fly and escape from predators. The presence of wings in birds is a structural adaptation. Not only that, birds have hollow bones. Hollow, Hollow. The bones are not dense, they are hollow. There is air inside. The hollow bones makes it easy for bird to be able to fly. So the presence or the possession of hollow bones in birds is an example of a structural adaptation. Not only that, there are some organisms, there are some animals like polar bears that are found in Arctic region, Arctic, like this. Arctic is talking about severe cold places on the planet. All right, they're usually found in places that are freezing cold. So these places are very chilling cold. And polar bears, an animal that they find in them, most of the time, they have thick furs, F-U-R-S, on their body, which will help to insulate them and prevent heat loss from the body. Not only that, we have foxes. Foxes also live in Arctic region, but in this case, the foxes usually have white fur, and the fur is to blend them with the environment. Don't forget, Arctic places are usually places that have ice, and when you have a place that is majorly made up of frozen ice, how does it appear? Whitish in color. And because of that, some foxes that are found in this Arctic region have white fur, so that they will be indistinguishable from their surrounding, from predators that might want to kill such foxes and prey on them. Not only that, we have behavioral adaptation. Behavioral adaptation is not what an organism possesses, it is what an organism does. For example, an organism that moves from a place to another place because of abundant amount of food there. If an organism moves from from a point A to point B, because there is higher amount of food in point B, that is behavioral adaptation, not structural. What an organism does to adapt itself is behavioral adaptation. But an organ that is present on the body of an organism that makes the organism to be able to adapt to its environment is what we call a structural adaptation. For example, a chameleon, for example, can actually camouflage itself. It can take the color of the environment where it belongs to. It can blend in with the color of the leaf or of the tree where it is present. That is an example of a structural adaptation, because it can use some chromatophore pigment on a skin to actually produce a color similar to that of the environment. Not only that, what about something like a zebra? Zebra has all these alternate white and black stripes on its body. What about tigers, for example? They have all these patches on their body. These are structural adaptation. Although you call it disruptive coloration, like this. So when you have animals such as zebras, such as all these panther, tiger, and so on and so forth, that have all these patterns and patches on their body, they exhibit a particular type of color. They blend in with that particular environment, making them difficult to distinguish from their habitat, or making them difficult to be seen or identified by potential predator. That is cryptic coloration. But you also have what they refer to as counter shading. Counter shading is exhibited by fishes, where a fish will have a different color in the ventral part. You look at the ventral part of it, it's going to be slightly whitish or silvery in color. And you look at the back, the dorsal part, it is darkish or brownish in color. So that kind of coloring, where certain part is whitish or silvery white, like in fish, and then the dorsal part is dark, we refer to it as counter shading. So organisms like fish exhibit counter shading, which is an example of structural adaptation. Organisms like chameleon, organisms like snake, they exhibit cryptic coloration because the color on their body can blend them in with their environment, making them difficult to be identified from their habitat by potential predators. That is what we refer to as cryptic coloration. Then organisms like zebras, organisms like panther, like tigers, that have patterns and patches on their body, which blend them in with the environment, making it hard for predators to see or identify them. We refer to such coloration as disruptive coloration. So let's move on. The next question. Which animal has a thick fur coat for insulation? A is elephant, B polar bear, C crocodile, and D parrot. I've explained this while I was explaining different adaptations to you. What will the answer be here? The polar bear. Polar bear live in Arctic region. And Arctic region are almost frozen places where there is huge amount of found in these places, needs to be able to save and conserve little amount of heat energy in their body. And these polar bears and also foxes, although foxes usually use their own fur to blend with their environment, but polar bear has this extremely thick fur that will help them to prevent loss of heat from their body. Elephants don't need any insulation because elephants are not found in cold places. They are found in tropical region. The same thing with crocodile. Crocodile are poikilothermic animals. They are cold-blooded animals. They don't need to insulate themselves. And if you look at parrot, actually birds, and birds don't have fur. What they have are feathers. So a parrot can only use its feather to be able to carry out insulation and prevent loss of heat from its body. The 48th one. Okay, mimicry is an adaptation where an animal A changes color, B copies another for protection, C hides in trees, and D bites other. As a matter of fact, the word mimicry comes from the verb mimic. Mimic means to actually imitate another person. So if I talk about mimicry, is when an organism or an animal copies another organism in order to be able to either escape from predator or to be able to survive in an environment. There are some organisms that when they see a predator coming their way, they lie flat, they lie motionless, and they resemble a dead wood, so that the predator can actually pass by without noticing them. For example, look at millipede around us. When millipede is crawling by, if you touch it, what happens? It just rolls up and remains stationary as if it is dead. Only when it notices that time has passed does it uncoil and then it goes its way. So mimicry is talking about those things, those activities, those behaviors of animals where they mimic, they copy, they behave as other animals in order to be able to survive in their environment, either by escaping from predation or to notice. There are some insects that will actually produce certain foul smell that will make them to be unpalatable like other insects, so that predators do not feed on them. That is mimicry. So mimicry is an adaptation where an animal copies another animal for protection. So these are some of the things you need to know about adaptation. A lot of questions do come from adaptation, from cell division as well. That's actually why you will notice a lot of questions under cell division, so that whichever way questions come from cell division, you'll be ready for that. And subsequently, on Monday, we are going to be taking our attention on like genetics, like evolution, reproduction, and so forth. If you have questions, I will entertain that before I go. Any question? Any question? Okay. What's the question?
The animals that give out foul smell, if you can state out the example so that we can know.
Yeah, I did mention that there's some animal that can actually produce certain foul smell so as to not be eaten by predators. Example is mealybug. She was asking if I can give example of that mealybug like this. Mealybug. A mealybug is the major example of an insect. It produces a foul smell. When such foul smell are produced, when a predator comes closer and persists and detects such a foul smell, it moves away from it, seeing it as being unpalatable and not something that can be killed and eaten. So that's an example. That's the immediate example of such an organism, mainly bug. Any other question? I can entertain you one more. Any other question? What is the mesophyte? Okay. All right. Someone is asking about definition of mesophyte. Now there are plants that are classified based on their habitats where they are found. So I'm not just going to restrict the answer to mesophyte alone, but I'm going to start from it. A mesophyte is a plant that is found in areas with moderate amount of water. Once again, a mesophyte is a plant that is found in areas with moderate amount of water. For example, all the trees that you find around us here, they are mesophyte because the amount of water, the amount of rainfall that is available to them is moderate. That's a mesophyte. Mesophyte are plants found in areas with moderate amount of water or moisture. The water there is not too much and it is not too little. Not only that, apart from mesophytes, we have hydrophytes. Hydrophytes are plants that are found in fresh water habitat. For example, talk about water lilies. We find them in fresh water, on top of water, floating on top of water. That is hydrophyte. These are plants that are found in fresh water habitat. And then we have halophytes. Halophytes are plants that are found in aquatic habitat with high salinity. The plant that you find in oceans, for example, oceans have high salinity, they have high salt content. So plants that are found in water bodies or in areas where there is high salt content, that is halophyte. Not only that, we have xerophyte. Xerophyte are plants that are found in desert or in area with limited amount of water. Those plants that are found in desert, in areas, arid area with very little or no amount of water, they are called xerophyte. Example of xerophyte is cactus. The plural of cactus is cacti. You have cactus around us. Even here in Ekiti, here you have them. People plant them in their houses. They can withstand high amounts of drought, whereas other plants can dry due to lack of water. Cactus can survive with little or no amount of water. That's why they are found in desert and arid areas. And the last type of plant we talk about are psammophyte. Psammophyte are spelled like this. So you have psammophytes. Psammophytes are plants that are predominantly found in sandy areas or sandy soils. So those plants that survive or are found in soils that are predominantly sandy in nature are called psammophytes. So these are the various kinds of plants that we have. Just to recap, psammophytes, these are plants found in sandy soils. Mesophytes, the question that was asked, these are plants that are found in areas with moderate amount of moisture or water. Hydrophytes, these are plants that are found in fresh water. And halophytes, these are plants that are found in water of high salinity, water with high salt content. And then we have xerophytes. These are plants that are found in areas like desert with little or no amount of water. Any other question? Feel free to ask questions if you have any question at all. Any other question? Okay, so I think in the absence of no